Now we have a last presentation by Professor Anatoly Viva, who will be talking about calculation of optimal values of measured lengths for accurate determination of length of small segments. That's a quite complicated title. So I'm looking forward to listen to your presentation.
Okay, good afternoon, dear. Thank you for invitation. I'm sure my
Yeah, we can see your screen.
We'll see my presentation.
Yes.
I must say I'm a senior lecturer. Professor is Litynskyi-Fys and Anatoly Tsirklevich. We are from Lviv Polytechnic, Ukraine. Thank you for invitation. We want to present our research with contain calculation of optimal value measurement with total station. Improving the accuracy of measurement distance is difficult because measurement contains systematic error. We offer a line angular method by measurement segment with total station. The result of our work you can see in this picture. This is formula. To obtain this formula, we use triangle. You can see in the right side, and sinus law. Sinus law connect the measurement to distance and one angle with defined distance c. For Formula 1 is sinus cosine law. I'm sorry, cosine law. Differentiation 1 we can contain for Formula 2. There is mean square error of distance c. In this graph, you can see when minimum mean square error obtained when distance d1 and d2 is equal. Now, when distance d and d2 equal, you can simplify law, sinus cosine law, and write formula. Formula 3. And mean square error of this formula distance c you can see in formula 5. Next, to obtain simplify formula, we use Lambert function, and this written in 6 formula. Let's find extremum for all variable, and we write 6.1, and solving this system you will obtain formula which call it for two offered Litynskyi-Fys. to check this formula on reference basis. In this slide, you can see a reference basis in Lviv city for calibration total station. For two side from basis, we install two devices developed by us. By formula, we calculate optimal distance, which for 10 meters equal 54 meters. And to point from basis 54 meter, we install total station. Measuring distance D1, D2 and angle gamma, we calculated distance C. In this table, you can see interval, calculated interval, 1 meter, 10 meter, and 20 meters. In this, you can see difference between ettalon distance and calculated with our method. This similar results we obtain when the calibration leveling stuff. To conclude, and I must say, this method increasing accuracy to 1 order, because this very high precise total station mean square error from technical characteristic is 1 millimeter. In table you can see difference 0.1 to precise higher to 1 order. You can see in this table. For accuracy have influence difference between shoulder. In this picture you can see influence for different shoulder, and for 1 meter this graph, and for 10 meter this graph. You can see that difference when we measure 1 meter. We must 10 centimeter. Yes, you can see it here. For measure 10 meters, you can 1 meter. 1 meter. Thank you for your attention.
Okay, excellent, excellent. I think we have time for the question too. So your presentation, Professor Vitali, was shorter. So please.